Hi everybody, this is Mr. Scott, and this is your screencast of the speed, time, and distance post lab that we did in class, and hopefully you learned something. So at the top, you'll notice that there's this quote from one of the best movie franchises ever. That's Luke Skywalker from Star Wars, and in honor of that, we're going to go ahead and use the laser pointer as a lightsaber when applicable. So at the bottom of this first section, you see that it tells you to describe your motion here. You should have probably put like heel to toe, you should have put crab walk, cartwheel, whatever you guys decided to do. The point of this was to try and get you to see that we wanted to decipher between instantaneous and average velocity when you got to the end of the lab. So that's why we chose a silly walk, and hopefully you just wrote something down there. Next, we had to make a data table, and you guys have already got a little practice with this with the bus lab. But anytime you make a data table, the most important thing is to always include units, because kids will always forget that, along with your independent and dependent variables, and possibly even what you're solving for. As you can see, I now have written in the things I need for my columns in my data table with units, and we're going to solve for the calculated speed here by taking the distance column and dividing by the time column for each trial. Now, unlike the bus lab, you guys were actually going to try and figure out what a mystery distance was after you calculate the speed. So you have two trials of calculated speed, and we were going to give you a distance that you didn't know, but you did know the actual speed of your silly walker, and you could also take the time in which it took them to travel the mystery distance. So a good exclamation here would be boom, something to this effect. So the next question asks, how are you going to use your two calculated speeds to be able to figure out one calculation for mystery distance? And it's almost like we do this for our own enjoyment, but we really don't. We do it to make sure you read the lab. Check out the next question, which says, using the average velocity from above. Make sure that you we'll be using the average of our two calculated speeds from before to then be able to plug in for just one calculation. You could also use both calculated speeds, do two calculations for mystery distance, and then average that, but it's just one extra step. Now, if you're not already trained, you need to be soon, because we will start taking points off of quizzes and tests. If you don't, write the formula first with no numbers, plug in the numbers in the correct variables and substitute correctly, and then write out the calculated answer with units attached to it. So something that would be an acceptable answer would probably look like this. And also note that I made up data here to try and make it more realistic, but we included in here the units while we're doing the calculation and the units at the end to prove that we know what we're solving for. Alright, so on to the questions. In your walk, was your speed always constant or was it irregular? So guys, in this lab, we intentionally made you do an irregular walk on purpose because we eventually wanted you to see the difference between average and instantaneous speed or average and instantaneous velocity. In the second question, we actually tell you once again what the answer was to question 1, right there. But we're also asking you which type of velocity or speed we're using. Was it average, instantaneous, or constant? Well, the right answer here is average velocity. And the reason is because we did a total distance divided by a total time interval. If we would have just asked you for the speed or velocity at any instant, that would have been instantaneous velocity. So imagine a speedometer on a car telling you the speed at any given second. And like we said, it's not constant because this wasn't a regular walk, so your best answer is average velocity. And the last question is just a practice question, trying to make you think about the speed equals distance divided by time equation. So, if the distance stays constant, what would cutting the speed in half do to the time? So I would like to think about it two different ways. If you look at the equation itself, speed equals distance divided by time, well, if we keep the speed in half, or cut in half, this side of the equation, the left side, is going to be half as big, which means that because of this equal sign in the middle, we need the right side to be half as big too. And if the distance is staying constant and not changing, then that means the only thing that can change is the time. So what do I have to do to the time and put out in front to make it half as big as a fraction? Because time's in the denominator, it needs to be twice as big, so that way we still get a half on each side. Now, if you don't like thinking about it that way, you could also think about it in terms of distance on a trip. So like if you were going from Glen Ellen to downtown Chicago, it might take you an hour to travel about 25 miles. Well, if we still travel the same 25 miles, but this time we go half as fast, then it should take us twice as long. And either way, that's the explanation we're looking for, something to that effect, and that the time doubles.